All right. Do you have your review material for your final?
Not today, because we're getting it tomorrow. We're working on it in class tomorrow, and then we are doing it over the weekend, and then up until the final. So, get it tomorrow. We had a quiz today,
All right.
and I thought it was okay. I mean, it was couple problems were like a little weird, but for the most part, it wasn't like life-threatening. So, yeah. So, I think today it would be a good idea just to go back and look at all the things we've done and maybe run some practice problems.
Okay.
Just, yeah, in the name of reviewing. So, yeah.
Why don't you look back through the chapters that are going to be covered in your final and see if you can find some problems that we can do.
My mom left her phone in the studio. Okay. So, what do we have? I guess polynomials would be something good to go over.
All right.
A little bit. All right.
That's what everybody seems to be covering lately. It's like I'm having, I'm having polynomials in my dreams. I mean, I 4 or 5 times a day I'll work with third-degree polynomials and how to factor them and stuff.
Oh, sounds terrible. Okay, let's see, he's really fond of, I'm trying to find the chapter with the I, where we first started using I and like radicals and things.
Okay, well that would actually come in quadratics.
Yeah, that's what I'm looking at now.
The first time you encounter quadratics, you get I. In other words, if I try to solve the following problem, help me solve this.
So you would take a -1 on the other side, subtract a 1, and then you take the square root of that. So you get x is equal to I.
Actually, x is equal to plus or minus
I.
the square root of 1, which is plus or minus I. And remember something about I. They always come in pairs. You never get an answer of I. When you're solving quadratics or cubics or quartics, whatever, if you get an answer in I, you got 2 answers in I. In other words, if 2 plus 3i is one solution, then 2 minus 3i is another. So that should help remember that plus minus in a situation like this. Because no, you need 2 solutions. Okay. How about problems that you can find, which are better because that more closely, it's hard for me to remember the degree of difficulty that you are working on.
I'm going to try to go back through the homework from last night maybe. Just because there were problems, I had problems with some of the things on the quiz today.
All right.
But, yeah, the annoying thing is that he didn't, I don't know, the homework we had didn't cover what was on the quiz, which is annoying, but.
Yeah. No, that's pretty typical from what I've heard.
Yeah. All right. Okay. So, we were doing synthetic division and substitution. So for example, one of them said, oh dang, where'd it go? See, the things he gave us weren't like, I can't find one that is similar to what we had on the quiz.
Right, I know exactly what your problem is. And I don't know what the solution is. In other words, how can you do problems that you don't know, that you've never heard before?
Yeah, because like I do my best to prepare for the tests and quizzes,
Right.
The homework and what we do in class, and then like all our problems had whole numbers, and nothing was imaginary or square rooted or cubed, and then today it was all fractions and imaginary numbers.
Let me give you one. One I came across the other day. Solve that. What's the first thing you think of when you think of factoring? What's the very first step that you should always look at? Sarah, you still there? I may have lost you. Are you back? Try logging out and logging back in. Hi, Sarah. I can't tell if the problem's on your end or my end. Well, one thing I was going to suggest is to log out of GoToMeeting and try logging back in. Let me give you the meeting ID number again. Why don't you write this down? 678-458-181. Now, it did occur to me that I get DirecTV, and that's how I get my internet access, so I don't know what they're doing with that dish up on top of the roof. That might be affecting things. I noticed I had trouble with Google's voice interpreter here. So anyway, try logging out, try logging back in, we'll see if that works. No? Some may have been. Okay. All right. Bye-bye. Oh, I don't know what that was. Must be a full moon out. Are we back?
I think
For the moment. I wonder whether that was on your end or mine. You think that was on your end?
so, because so we have this really dumb Wi-Fi router, and occasionally the lights will go red on it, which means it's not working. And if you get one of the top few lights, you can restart it. But if you get one of the bottom few lights, you have to turn everything off and turn it all back on.
Wow. Okay.
All right.
I thought of this problem when we, I don't know if you saw this when I first wrote it or not. Here's an interesting polynomial that I came across the other day. It incorporates quite a few things about polynomials. Any ideas on how to start this?
No.
Always look for a greatest common factor as your step one.
Yes, you have x, so you can pull that out.
Well, let's try that. What's left?
X to the power of 4 plus x squared minus 6.
Okay. Now, does this give you any ideas?
You could do substitution.
Good. Okay, so u equals what?
U would equal, oh gosh, x squared.
So how can I rewrite this as a quadratic in u?
Yeah. So then you could do u squared plus u minus 6.
Okay. Factor that.
Well, u plus, plus u minus, no, plus,
Plus minus is right because of this negative 6.
so then it would be plus 3 minus 2.
Okay. Now let's go back and resubstitute. So what does this become? Instead of u
Wait,
plus 3.
What? Wait, don't you have to solve it? I'm confused on how you
Well,
do it.
there's a couple of ways we can do it. We can solve it for u and then go back up and solve it for x. But it actually might make more sense to you if we resubstitute right now.
Okay, so you would put in u plus 3 and u minus 2?
Well, instead of u plus 3, if I resubstitute, what is u?
X squared plus 3 and x squared minus 2? Okay, I see what you're doing. I was just confused because normally I go and solve.
Right. That's what we had done in the past. But as long as I had this x sitting out here, I didn't want a combination of x and u because that doesn't make much sense. So we can arrive at that point very easily. And now we can solve it from here. So if this whole thing's equal to 0, tell me the solutions.
Okay, so you have plus or minus 2.
Okay, hold on. No.
I
Close. Let's start from the left. Always start from the left and go right.
Okay, so then that 1 would be a 0.
Okay.
Right, that 1x1.
And now solve this to give you your other two solutions. Or I should say to give you 2 more solutions. So how do we solve that?
So you would subtract 3 from both sides. And then take the square root of that.
Is that?
So that would be plus or minus the square root of negative 3.
Okay, we'll leave it like that for the moment. And then let's go back and solve this one. The third term. in our product?
So you would, yeah, take the square root of both, and then you get plus or minus 2, square root of 2.
Square root of 2. Okay, so now let's list all 5 solutions. There's 1. I know there's 5 solutions because this started out as a quintet, or whatever they're called, 5th degree polynomial.
Okay. So you would have 0 as 1, and then you'd have plus negative square root of negative 3.
Okay, let's convert that to imaginary notation.
Plus I square root of 3. Square root of 3i.
Yeah, you know, I prefer square root of 3i, even though it has the problem of accidentally including the I under the radical sign occasionally. This is really more in standard format. Standard format is A plus BI. So if you have a coefficient, it should go in front of the I. Okay, what's another solution?
Then you would have negative square root of 3i.
Okay. Another one?
Then you would have positive square root of negative 2, or square root of 2, sorry, and then negative square root of 2.
So how many real solutions do we have?
So you have 3 real solutions?
Okay. How many irrational solutions do we have?
4?
Just 2.
2? Oh, just the, yeah.
And then how many complex solutions do we have?
2?
And integer solutions? 1. While you were away, I found this. This might be helpful. This is probably out of your book. This came from my other student that I don't think he's in your class, but I think he's in a class taught by the same teacher. I frequently get the same problems from both of you. So I don't know. Did you look in your book and find some problems you wanted to do?
You can also doing what I have with the test. That's my book. The picture you have? Like the same font.
Unfortunately, the audio is now giving me problems, and I'm just having a hard time hearing you. I can't hear what you said.
Oh, sorry. I said it looks like my book.
Okay, good. Is this a chapter you want to look at some of these problems?
Yeah, some of these problems. What I was looking for, just like 10 seconds ago, were problems like what I had trouble with on the quiz today.
Well, go ahead if you want to. If you can find some of those, let's do them for sure.
I can't really find any. I guess 14 could be similar.
Okay. So 14, use the factor theorem to determine whether the binomial is a factor of the given polynomial. So they're asking if t plus root 2 is a factor of that.
All right.
All right. So the question is does t plus root 2 a linear factor, no different than t minus 2 or t plus 3, it's just t plus a irrational number. So is that a factor of this? Well, let's try to do long division. Or, better yet, we could try to do synthetic division. First of all, let's do it both ways. What do I need to finish writing inside the radical sign if I'm going to do long division?
Okay. So, wait, for long division?
Uh-huh. Same thing for long division as you would do for synthetic division. You have to account for the missing variables of t, or the missing exponentials of t. Notice there's no t cubed and there's no t squared. So I'm going to, yeah, so I'm going to put dummy variables, is what they're called. And then we have a plus 4t and a plus 4. So, what's the first step in long division?
Okay, I don't know. Never learned long division except for last week or last Monday. Yeah. Last week.
Okay. Are you going to need to know it on your test?
No, I think we're using synthetic division.
Okay, let's turn it into synthetic division really easily. What's going to go in my box, and what are the coefficients across the top going to be?
So in your box, you're going to get a negative, or the square root of -2?
No, then you had it right the first time. Negative square root of 2. Because if this is a linear factor, it means t is equal to negative square root of 2. Right?
Yeah. Okay.
Now the coefficients across the top?
You would have 1, 1, 0, 0, 4, 4.
Okay. And for this to be a factor, this needs to be 0 when we're done. Okay. So I'll point my cursor, you tell me what to write.
Alright, so bring down the 1, and then you multiply it by negative square root 2, so you get negative 1.
Negative root 2.
Negative root 2, yeah.
You see? In other words, I'm multiplying negative root 2 by 1, so that gives me negative root 2.
Yeah.
Then I add these two.
Okay.
That's the solution when I add them.
Okay.
You see what I'm doing?
Yeah, I see this. Okay.
Okay. Now, multiply. In other words, we end up with binomial terms. Much like when you do synthetic division with imaginary numbers, you also end up with binomial terms. It's fine, no problem. We'll just leave it as a binomial term. In other words, that's what goes there. Okay, what goes here?
The 1 minus the square root of 2?
No, got to multiply it by that.
Oh, sorry, yeah. Jeez, okay. So you get the negative square root of 2 times 1 is negative square root of 2 times 2 times 1.
No, you were right. Negative root 2 times negative root 2 is positive 2.
Okay.
I'm going to put parentheses around these just so that it becomes clear. Okay, and then of course when we add that to 0, we get that. Now multiply that by that.
And then, so you get a 2 from the regular 2, then plus 2 times this negative 2,
which is
negative root 2.
Like that. Okay, and we add that to 0, we get, sorry about that pounding. Man,
Okay.
I just hope they stop when it turns dark.
Yeah.
Okay, now let's see, multiplying that. What do we got? We got minus 2 root 2. The biggest danger is it's going to make me go crazy. Plus 4. I mean, I've read about them doing things with torturing prisoners with sound. I'm beginning to understand it. I'm beginning to understand how that could work. Okay, when we add that number to 4, we get 8 minus 2 root 2.
Which is equal to 8 minus 8 squared root 8. 8 minus the square root of 8. Right? But that doesn't matter because it's still 0. Or it's not 0, which means it's not a factor.
Well, that was an interesting observation. I don't know that we want to convert it yet. Let's go ahead and multiply this, do this last multiplication here. So we get minus 8 root 2 plus 4. Do the last addition. It does not, it's not equal to 0, right?
Yeah, so
t plus root 2 is not a factor of that polynomial. Use the factor theorem to determine whether the binomial is a factor of the given polynomial. And the factor theorem basically says that if we don't get 0 as a remainder, then it isn't. Right?
yeah.
Okay. Where did I see? I saw this problem with you. We had a session Monday. Yeah, okay. Well, I don't want to give you a problem, so I've already done with you. All right. So is that something like maybe you would have seen on a test that you hadn't had homework on?
Yeah, it was similar to that, stuff like that with the I and
Okay.
everything.
Okay. Well, good. Let's continue on that route. Let's do 15. Or I'll tell you what. Let's do 16.
Okay.
Is this a solution or a factor of this? Did I lose you, Sarah? Are you there?
1 second. You're back. Can you hear me?
I can make out about every other word, and combined with the hammering, I'm not sure I can, but let's see. Let me think about this problem for a moment. Okay, so let's do synthetic division. Can you hear me?
Yep, I can hear you now. There's just
Okay.
some weird audio.
Let's see what happens when we divide this into this trinomial. Goes here.
So, you'd get a negative 2i.
Okay. Now when you add these two together?
You get a negative 1i.
No. In other words, you get 1 minus 2i.
Okay.
When you add 1, when I add 1 plus a negative 2i, then this is what I get, 1 minus 2i. Okay. Now multiply this.
So, okay, negative 2i plus minus 2? Would it be? No, because you have...
Okay, so what is minus 2i times minus 2i? Just do it algebraically. What do you get?
Wait, so you multiply... Okay,
Yeah,
here's what I
in
started.
other words, we multiplied that by the 1 to get this. Now we have to multiply that by the minus 2i to finish that.
So you don't... so would you get...
So
would
you
it be
get
4i?
4i squared. What does that number equal to?
Negative 4.
Okay, so negative 4. Add those two. Add 4 plus this. What do you get?
So negative 4.
The 4's cancel. So
Oh, yeah.
we're left with just the minus 2i. Multiply it again. What do we get up here?
Negative 4, and then you get 0. So it makes
And that proves that it is a factor. And that's all we would need to do here. We don't need to go any further. Because all it said was use the factor theorem to determine whether the binomial is a factor of that given polynomial. So here's a thought that just occurred to me. He gives you homework, questions 1 through 15. On your tests, he draws from questions 16 through 30.
Yeah, okay, so...
Maybe or not?
Yeah, stuff like that.
Okay, so if you want to prepare for your homework, do the problems that aren't given to you in the homework. Sounds to me like that's what's going on.
All right.
And it's the only real way we have of practicing for that. In other words, we don't really know what he's going to come up with that he hasn't given you already, but my guess would be it would be in the higher number exercises from your homework.
All right. I'm kind of wondering if I was going to go over it. So that was my senses.
Okay, so
All right.
we just did synthetic division with irrational numbers, and we did synthetic division with imaginary numbers. Okay?
Okay.
About 17. Is this one you've done?
No, I haven't.
Well, first of all, let's notice some stuff about this. Is there any other way we could solve this without knowing one of the solutions? They're telling us that one of the solutions is minus 3, and we'll get to that in a moment. But you got any ideas on how to solve that without knowing one of the solutions?
Wait.
Cubic.
Well, you have to. Yeah, you have
Cubics.
to.
There's only going to be 2 different ways to solve cubics. One is by grouping, and the other is by using the P over Q, which is tortuous for anybody. So the very first thing I look for when I see a cubic is to see whether it will group or not. Will this group?
Wait, sorry, the audio is cutting off again.
Yeah, I apologize.
Okay.
Will this group? You know what I mean when I say grouping?
By breaking them into...
Yeah. In other words, what I look for when I look for grouping is the ratio of that coefficient, which is 1, versus that coefficient needs to be the same as the ratio between that coefficient and that coefficient. And it is in this case. So we can actually solve this pretty easily without knowing a solution. So let's group it. Let's group these two together, and let's group these two together. So how do we do that? Well, I'll start. It's the second part that's tough. Tell me what sign to put right there and what to put in the parentheses.
Okay, so you would put in, so you put in okay, wait, oh gosh, this is like from last time ago. Okay, so you put in a negative.
Correct.
And then you would put in 3x.
3x plus 9.
Oh, look, I remember things.
Okay. Now factor each expression. Find the greatest common factor in the thing on the left. What is it?
All right, so you would, for this one, you'd have to pull out an x.
X squared.
Oh, yeah, duh.
And what's left?
Plus 3.
And for this one, you pull out a what?
A 3. And so you get x plus 6.
And the key is that this be the same as that. And now we can factor this again, factoring out a binomial. So what's my next line?
The next line would be, wait, you factor, wait, are you putting it in factor form?
Yeah, in other words, I want to factor that.
Yeah, okay. So wouldn't you put x squared minus 3 and 1?
Uh-huh. But let's start with, always start on the left with what you're factoring out. So what am I factoring out?
The things in the parentheses?
Yeah, x plus 3. What's left?
X squared minus 3, sorry.
You see what I did? So now all of that's equal to 0, and it's easy to solve. Well, x is equal to minus 3, or x squared is equal to 3, meaning x is equal to plus or minus the square root of 3. So there's our 3 solutions. And we didn't even need any of their help. However, let's go back and do it the way they wanted us to do it. Can you hear me, Sarah?
Yeah, I can hear you a little better now.
Okay.
It was cutting off earlier.
I know. I'm hearing about half of what you say, and I'm sure you're hearing about half of what I say. But we'll see if we can get through it here. Okay, so I'm going to go back and do it the way they wanted us to do it. If we didn't know that you could group, and if we, in other words, we were able to solve it with no information from them. Well, what they've told us is that this is one solution. So how do I use their one solution to come up with the other 2 solutions?
So you could do, yeah, the substitution with the synthetic substitution, right?
Well, or synthetic division. Synthetic substitution and synthetic division really are the same thing. The beauty of synthetic division is that you're left with the resultant quadratic. Synthetic substitution really only tells you whether that thing is going to be a factor or not. It gives you the same thing regardless. So let's synthetically divide. What do we got?
So you would get 1 times the negative 3, which would be 3, right? And then add them, which is 0. And then you multiply that, which is 0. So you add that, and it's negative 3. Times negative 3 is 9, which gives you 0.
So what's the rest of my quadratic? In other words, I know this is one linear factor. What's the other?
X squared minus 3.
Yeah, which is exactly what we came up with when we did it by grouping. And so now we can get the other 2 solutions by solving that part there. So in this case where they give you a cubic and they give you one solution, you just do synthetic division and you'll come up with the resultant quadratic. And you can always handle a quadratic. worst case scenario is you got to put it into the quadratic formula. But that's the worst case scenario.
Okay.
Okay. Should we try 19?
Yeah, sure.
Okay, I'll let you take it from the start.
So, so you would start out with t cubed, right? Or no, positive. Would it be? You put in -4, right? Because in the box.
Right. Correct. -4 goes in the box.
And then you get 1, 0.
I didn't hear you, but I'm sure you said that.
Yeah.
Okay?
Okay. And then you bring the 1 down, and you multiply -4, -4, and then you get -11 plus 16, which is 5. -4 is -20. 0.
So we got x plus 4 is 1 factor. What's the other one?
Would be x squared minus 4x plus 5.
Okay, and then factor that further.
It
doesn't. It doesn't, does it? So now what? So it wants all solutions. Solve the equation. So we can't stop here. We've got x equal -4 as one solution. What are the other two?
You can't factor it, can you?
Not in the easy way.
No, so you have to do the quadratic.
Okay? X equals what?
So 4 minus square root of 16 minus 4 times 1 times 5 over 2.
Okay? What's the next line?
So then you would get 4 plus or minus 2 times or 2 times 2i over 2.
Uh-huh.
And then the 2 and the 4 would cancel each other.
So what's the last line?
So 2 plus or minus I.
And those are your other two solutions. So the factors, if I wanted to write out 3 linear factors, they would be this. What would the next two be?
X plus 2 plus I? X.
Take it one at a time. Don't try to do it all at once.
So
the first thing we're going to do is subtract whatever one of our solutions is. And then we're going to subtract the other solution. So what goes in here?
2 plus I.
And what goes in here?
2 minus I.
And now, finally, get rid of the inside parentheses. What do I have?
Yeah, X minus 2 plus I. And then X minus 2 plus I.
And there's your 3 linear factors. Not that they asked for that. They didn't. But I want to make sure you understand that's what happened. I mean, when you solve for solutions, your linear factors are always x minus the solution. So when they gave us the solution of minus 4, we knew that x plus 4 was one of the linear factors.
Okay.
All right. Why don't we call it a session?
All right, thank you so much.
Yeah, really, I felt like
Sorry for the weirdness with the...
Oh, well, I'm not sure. I think it might be on my end. The hammering is definitely on my end. So, gosh, I've never prayed for dark like I'm praying for dark right now. Get them off my roof. So, I will talk to you on Monday, I think, right?
All right.
If you feel like you need an additional session before your final is when? Next Wednesday?
Next Friday, or Thursday, I believe.
Okay, so you'll still have 2 sessions next week then?
Yeah.
Okay, sounds good. I'll talk to you Monday.
All right.
All right, Sarah. Bye-bye.
Thank you. Bye.